Hi everyone, welcome to another Science at Home. Today we are going to make water defy gravity. So what you will need is a bowl, preferably large enough that you can fully submerge a glass in it, a small glass, water, and just to add a little bit of fun, we're going to use food coloring because what isn't more fun with color? So your bowl doesn't have to be clear. That's just so that you guys can see everything and see that it's working. So I'm going to carefully pour the water into the bowl here. And I need a little bit more, so I'm going to use a second pitcher. Go ahead and fill it right on up to almost the top. Get my food coloring. And this is just gonna, like I said, you don't have to use food coloring. It just kind of, color makes it a little bit more fun, and it's gonna make it easier for you guys to see what's going on too. All right, swirl that a bit. There we go. Okay, so next we're gonna take our glass and we're gonna put it into fully submerged in our, got a little air bubble I'm trying to get out, there we go. Fully submerged in our bowl. Then we're going to tip it upside down so that the opening is at the bottom. Next, go ahead and lift up. All right, do you guys see how the water is staying in there even though it's above the rest of the water level? And watch what happens when I break the surface. All right, so the water stays in the glass until it breaks the surface. Until then, when the cup is inverted like this, the water will stay in the cup despite being above the water level. Now, why does this work? Air pressure. So air pressure is all around us. It pushes on everything. The pressure of the air on the surface of the water is greater than the water's desire to go back down. So the force of the pressure is pushing the water up into the glass until the surface is broken and air can get inside. Then air comes inside, gravity makes the water come on out. And there's another neat experiment we can do to demonstrate this. So I'm gonna back on up here, move my chair out of the way, and move this lovely table right here. And I'm gonna go ahead and get some water in my glass. I'm also going to grab this Post-it note here. Now, supposedly, if I place this Post-it note here and flip the glass upside down very quickly, what do you think would happen? The water come out, the Post-it note fall down. Well, let's give it a try and see what happens. No guarantees. That is why I have this table here in case it does not work, so that I do not make a mess. So definitely do this one somewhere where you have a sink or a tub, something like that, in case the water does end up coming out. Just like that. So theoretically, how that was supposed to go was the water stays in the glass and the Post-it note is stuck to it. Now, this would be because of, again, the air pressure. So the pressure, again, of the air is pushing up on the card and the water. It's trying to go from high pressure and it's pushing in on a place with low pressure. Okay? So imagine a force going from high to low. It tries to equal itself out. And so that's what the air is trying to do when it has one area with more pressure than the other. But sometimes there's a barrier and it can't quite work that way. So I hope that makes a little sense. I just thought this was a really fun experiment, but definitely go ahead and give the glass a try. See if you can get it to work out better than I did. There's a lot of great info about this on the internet. And so take a second, look it up, and see if you can make things work. Bye, guys.